All right, so we write down this problem. Done. Now, let's go ahead and write the equation to represent this situation. So, first of all, notice that since we're increasing by 10% every year, as soon as I see that it involves a percent increase, that tells me that I'm going to use that A of t equation that we've been using so far. So we're going to go A of t equals. So the first thing in my A of t equation is the value of P. What does P equal in this?
Principal.
Yep, P is the principal, which in this case our starting amount is 1. So I'm going to do 1 times, remember it's 1 plus R. What is R here?
0.3.
Remember we take our percent and we turn it into a decimal. Turn our percent into a decimal. I do 10% divided by 100, which gives me 0.1. So yes, R is 0.1. And then that's to the power of t. Now notice we don't know what t is here, but that's why we're writing an equation, not just finding a value. So it's going to be to the power of t. Now I want to clean that up a little bit though in order to move forward, because we're actually going to be doing a decent number of calculations with this same equation. So how can I simplify it? Well, the A of t is still going to be A of t over here, right? What's 1 plus 0.1?
1.1.
Yeah, that's just 1.1, right? So let's do that. So it's going to be 1 times 1.1 to the t. But of course, that can even simplify, right? Because 1 times anything is just itself. This
1 times
this 1 right here doesn't really have to be there, right? Because 1 times 1.1 is the same thing as just 1.1. So I could then rewrite this whole thing just as 1.1 to the power of t. By simplifying the equation now, I'm going to make my life easier later. Because what we're going to be doing now is we're going to figure out how much will this little dollar stock be worth after all of these times. And so we're going to have to figure out every single one of these values. And in order to do so, use the equation. And by simplifying it, it's so much easier to then put in your calculator, right? So it's time to actually put in your calculator. Please figure out now each of these values. So when we actually plug these in, this is what we should be looking at. Now, the interesting thing about answering all of these different questions here is what we've actually done is we've created a table of values. Because notice I could just take all that information and treat them like x's and y's. If I did that, then I could really see that, well, I just made a table of values. I made a table of values that I then can actually use to make a graph for this situation. And that's what we're going to be using this for now. We're now taking the word problem and going into a graph with it. And that's going to let us be able to understand the situation better. So now we can actually go ahead and make a graph from this table of values. So let's go ahead and start plotting some numbers. Right. So I got to plot 1, 1.1. Where does that go? What's my scale? All of a sudden we have to think a little bit more ahead here. Now for this first one, I've made this easy. You notice I made the dark lines every 5?
Yes.
And so by counting those, we can see that if we just go up by 1s, we can actually fit all of our x values that we came up with on here. If I go up by 1s on the y, I can also fit them all on the y. I made this one easy and straightforward. Go ahead and label those numbers on there, because we need to know where those numbers go to. But as we go forward, you're going to see some later problems where we won't necessarily go by 1s. But of course, we'll start with a nice easy one here. So now I can actually see, when I say 1, 1.1, I can know what I mean by that, because I'm just going by 1s. So that's going to be over here. Over 1 and up 1.1. Now remember, for 1.1, for these decimals, estimate the best you can. You're not going to be perfect in putting it at exactly 1.1, but just get as close as you can to it. And then we go to the next point in our table, the 5. So we go to 5, 1.61. Okay, so like 5 and 1.6. I doubt we're going to be accurate enough for that 6.1 to matter. So I go over 5, so that's the first of the dark lines, the dark grid lines. And we go up to 1.6. Notice that's not up a whole lot more than our first point was. It's like just over 1.5 up. All right, next up is 10. When next is 10, you can see we're at about 2.59. I'm going to think of that as like 2.6. It's just over 2.5. So I go over to the x value of 10, and I go up to about 2.5, maybe just above it. And then we go to 15, and so on. Now once we plot our points, this is about where they should be looking. As you plot those, remember, be thinking like when you plot the 17.45 here, you know it's between 17 and 18, so that's where you're focusing, and then it's just a matter of, well, maybe just a tad bit below half or right around half, way between them. And so we get those points, but notice we haven't exactly filled our graphing grid yet, right? So I feel like we should be able to fit a few more points on here. Well, actually, first of all, there's one point that we didn't bother to put in this table, but it's actually really easy to plot. Because anything to the power of 0 again is 1. So actually we could go ahead and we could also put that point in right back here. We could put the point at 0, 1. We always can start with that point. All right, but then on the right side, yeah, we got more room. So I want to extend out our table a little bit. So we've got this much going, and now I want to add a few values to my table. Well, I just did like all the 5s up to 30. It would make sense to next go to 35 and see what that gives us, and 40 and see what that gives us, and just keep going until they'll no longer plot on the grid. So go ahead and figure out what 35 would give us, then 40, until they don't fit anymore. All right, so we do those calculations. When I do 35, 1.1 to the 35th power, I get about 28.10. Okay, so I can go ahead and plot that point. So basically that's just a tiny bit above 28. And then I go to 40. So I do 1.1 to the power of 40, which gives me 45.26. Notice that's now off my grid. Because remember, my grid, my y values only went up to 30. So I can stop there. So now I've plotted my points. I've gotten to the edge of the graphing grid. Now that I've done that, I can go ahead and draw the curve that goes through those points. Now, when you draw it, make sure you are neat with it. We've been practicing those neat graphs for a while this year. Now you're applying it to the exponential. Draw in the smooth curve that goes through those points, because we're going to be using that in a moment. Right now, we want the nice, neat graph here, because I can now use it to figure out problems like this. When will this stock be worth $13? So write down that question on your paper there so we can be able to look back at it and see how we can know this. So we're looking to see when will the stock be worth $13. Now we can use our graph to figure that out, but there is a potential pitfall here. Because I'll see some people that'll be looking for when this is 13 down here, and I'll be seeing some people where they'll be saying when is this 13 here. Because it doesn't say when x is 13 or when y is 13. So there really is one more step we should probably take with our graph.
Find a conversion.
We should label what the axes actually mean. What was playing the role of x when we made this graph? Was it the a of t or was it the t?
T.
It was the t. And so I'm going to go ahead and label my horizontal axis as time, or years. Which means that my vertical axis, up and down, is the amount, the dollars, the money. And by labeling that on your graphing grid, as you've just done here, what that does is it lets us know exactly what we're looking for. Because now if I'm looking to see when is it worth $13, that tells me to look on my graph to see the amount is 13. So basically, a great way to do this is you take a ruler and you hold it up against your graph And you just have it go straight across at 13 there and see where it intersects.
27.
And so that's what we're looking for there, that point. And so you can see that that happens, yes, at 27 years.
It's that squiggle what looks like C.
But notice this is also why we have to make an accurate graph. We need our graphs to be accurate when we sketch them in so that we can actually look at it and tell this information. If we're a little bit lazy with it, hate to use the word, but sometimes that's what it is if we skip a little bit too much and just kind of say, yeah, it's kind of like this, we won't be able to estimate anything from it like this. So you really have to be able to do this work. Now to practice that idea, please take a moment and answer this question. When will the stock be worth $20? All right, so again, I'm looking to see when the amount is $20. So I'm looking to see when it's 20 up here. So basically I'm looking right along this line. I'm going to grab a ruler usually to do this on my paper. And I'm going to hold the ruler up on the 20 line. And so I'm going to be seeing this. And I'm looking to see where that crosses the graph. Now, of course, our graph is maybe not entirely perfect, but we can get a pretty good idea if we look closely at it. And yes, sometimes you have to look pretty darn close at this in order to be able to see what's going on.
Holy. It doesn't.
But notice it doesn't go through
31.5 years.
at a nice, pretty point, right? It's not perfect. Well, with these sorts of things, it's usually not perfect. Usually it is kind of in between. So we have to make an estimate here. So I'm going to say that it's going to be a little bit above that grid line. Now, I of course zoomed in. Let's see what those lines are actually at. That means that it's between 31 and 32. Looks like it's a little bit closer to the 31. Now, I'm going to go ahead and say that it's going to be about 31 to 32 years. Depending on how we're answering the question, how we're thinking about it, you'll probably tend to think of it as, well, it's really going to take us 32 years because after 31 years we aren't there yet. But for now, if you say 31 to 32, or I'd also be happy with like 31.2 or 31.3, whatever you're estimating that to be. We're just estimating that it's going to be right around in this area because that's what we need to know. We need to know when is it going to get there.